Okay then, now we have 231. The 231 I don't think is going to give you too much trouble. There's an incline, there is no friction, there is an angle theta, there is no friction. And there is here an object. And the object is going to slide down. The object has mass m, so there is the gravitational force mg. I always, when I have inclines, always separate it in an x direction, along the incline, and in a y direction perpendicular to the incline. And the reason why I do that is that I know that in the direction perpendicular to the incline, there is no acceleration. The object is not taking off from the incline, the object is not pushing through the incline. So, for sure, the acceleration, and therefore the net force on the object, perpendicular to the incline must be 0. So all you have to deal with are the accelerations along the incline. Alright, so now I'm going to decompose this one in the x direction, which is mg sine theta. In the y direction, it is mg cosine theta. Of course, it's in the negative direction. And now the Planck has to push back in exactly this direction, call it n again, in order to cancel out this mg cosine theta. If these two didn't cancel out, there would be an acceleration in the y direction, which is not the case. And therefore the n must be mg cosine theta. Can there also be a force from the Planck along the Planck? The answer is no, because it's being stated that there is no friction. If there were friction, there would be a force in this direction, and we will deal with that later in 801, but not now. So the reason why n is mg cosine theta is that the sum of all forces in the y direction must be 0, otherwise there would be an acceleration, and so these two must cancel each other out. So let's now look in the x direction. That is along the Planck, so to speak, along the incline. We have an acceleration, which is g sine theta. It's reduced. If the Planck were vertically up, if theta equals 90 degrees, notice that you would have an acceleration g, which is completely natural, completely consistent with your intuition. The lower you make theta, the lower becomes that acceleration. In the y direction, n, which is vertical to the slope, it's the reaction force from the slope onto the object. We know that n equals mg times the cosine of theta. Well, you're being asked what the acceleration is along the slope. You know theta and I think you know g, so that shouldn't be too difficult. And you're being asked what n is, and I think you know what the mass is of the object, and you know theta, so I think you will have absolutely no problems with this whatsoever.